Now that we know what are the power functions, which the standard form is y equal to k x to the power of p, we learn how the graph look like for different value of p. So now in this exercise they're asking us find limit of x to power negative 4 as x approaches infinity. So we need to know how this look like. X to power of negative 4, this is exactly the same as 1 over x to the power of 4. We just learned that all the even negative exponents like x to power negative 2, x to power negative 4, x to power negative 6, they all look like this. So x goes to infinity, positive infinity, this graph will go to, it's going to hit this line, which is line, this is 1, that's 2, here is 0, it's going to hit 0. So the answer will be 0. Another exercise, same as limit. What is limit of t to power negative 3 plus 2 as t approaches infinity? So for a question like this, we need to break this one down to limit of t to power of negative 3 plus limit of 2 at t approaches infinity and t approaches infinity. So for this one, the answer will be 2. So far we have 2. So now we need to decide what about t to power of negative 3. So t to power of negative 3, t to power of negative 5, t to power of negative 7, we learned that all of them will look like something like this. That's the graph. So as t goes to positive infinity, this is positive infinity, t goes to positive infinity, this graph will hit 0. So the answer will be 0. 0 plus 2 will be 2. Let's have another exercise. So they're asking us describe the behavior of y equal to x to power negative 3 and y equal to x to power 1/3 as x approaches 0 from the right, same as 0 plus. And part B, they're asking us x approaches infinity. So in order to answer this, we need to graph both of them. X to power of negative 3, this is same as 1 over x cubed. 1 over x cubed, the graph look like this. And x to power 1/3, the graph will be look like that. This is same as cube root of x. So x goes to 0 plus. That means we are going from the right. We are getting to 0 from this direction. As we're getting closer to 0, this graph will go up. So it will be to positive infinity. So this will go to positive infinity. For the cube root of x, when you approach 0, you will get to 0. So this will go to 0. For the part B, they're saying x goes to infinity. So So x goes to positive infinity, this graph will touch 0. So this will go to 0, and this will eventually, so it slowly will go to positive infinity. As x getting larger here, the value of y getting larger and larger. Like cube root of like 100 million. So it will be a big number. So it will eventually gonna go to positive infinity. Another type of question on chapter 11, section 1, they give us 2 points, like f of 1 equal to 3/2 and f of 2 equal to 3/8. They're asking us find the possible formula for the power functions. So we need to come up with f of x equal to k times x to power of p. So in order to solve that, we need to solve for k and we have to solve for p. Same as exponential function, this is x, that guy is y. This is x, this is y. So I'm going to write 3/2 equal to k multiplied by 1 to the power of p. So this is my x. Instead of x I put 1, instead of y I put 3/2. For this point, which is 2 comma 3/8, I will put 3/8 equal to k to the power of p. So we have 2 equations, 2 unknown. This seems simple because 1 to power of p is 1, therefore k equal to 3/2. So k equal to 3/2. Now I apply k over here to solve for p. So we have 3/8 equal to 3/2 2 to the power of p. So I'm going to cancel this 3. This is going to be 1 over 4 equal to 2 to the power of p. Then the p here should be, so instead of this 2, I can put 4 to power of 1/2 p. I'm just trying to don't use log and just make a same base. So 4 to power 1/2 is 2, so we didn't do anything wrong. Instead of instead of 4, if I make it 1 over 4 to power negative 1/2 p, so 1 over 4 is same as 4 to power negative 1. Negative 1 times negative 1 gives us positive, so still is everything's good. So we have 1 over 4 equal to 1/4 negative 1/2 p. So the bases are same, then negative 1/2 p should be equal to 1. So 1 equal to negative 1/2 p, then p should be negative 2. So we solve it. The final equation, f of x equal to 3/2 x to power negative 2. Polynomial. So we're going to talk about polynomials. P of x equal to an x to power of n plus an minus 1 xn minus 1 plus a1x plus a naught. So This will be the degree of polynomial. A of n will be the coefficient. This is the highest degree. This will be the leading term. And this is leading coefficient. And if you make it from highest degree to less degrees and no degree at the end, this will be the standard form. For example, p of x equal to 3x to the power of 6 minus 2x to the power of 5 plus 4x squared minus 1. This polynomial has a highest degree is 6. The leading coefficient is 3. We have 1 term, 2 terms, 3 terms, 4 terms. Now if I ask you guys what is the limit of p of x when x goes to positive infinity, this will be very complicated to analyze this polynomial. So what we do, we say that this polynomial, it will behave same as x to the power of 6. So on the long run, on infinity, on positive or negative infinity, any polynomial will behave as same as the first leading degree. So if you know what's happening to this graph, it will be same as this graph. X to the power of 6 is even, positive even, it will be look like u. So when we go to positive infinity, this graph will go to positive infinity. So this will be positive infinity.